Hi, my name is Justin Lara. This is a Scenario 2 Football Crazy assignment for Aviation 430 Multi-Engine Ground at Liberty University. In this scenario, I'm taking a couple friends to Dallas for a football game. I got one friend that's a little nervous about flying in a light twin and another friend that likes to ask a lot of questions. With these two friends of mine, I think I'd have to over-explain everything, and it's never a bad idea to kind of think out loud and make sure you don't skip any steps. Every pilot knows we need to scan our instruments throughout a flight to ensure everything is going according to plan. However, there are far more things you must consider than just what's on the gauges. The 5P check, which is done at multiple stages throughout a flight, scans these other variables to detect issues. According to the PAC, the 5P check should be done during pre-flight, pre-takeoff, hourly or at midpoint, pre-descent, and prior to the final approach fix or the traffic pattern. To try and reassure my buddy that's worried about the flight and satisfy the interests of my other buddy, I might explain to them my thought process while completing the 5P check and allow them to make inputs of their own. The plan contains the basic elements of cross-country planning: weather, route, fuel, publications, currency, etc. The plan is often updated throughout a flight and is responsive to changes in the other 4 P's in weather. The plane consists of mechanical and cosmetic issues. I'll talk a bit more about that later. The pilot consists of everything included in the I'm Safe checklist and more that can affect your ability to perform as a pilot. The I'm Safe checklist includes illness, medication, stress, alcohol, fatigue, and eating. Passengers include the health and comfort and safety of the passengers, as well as making sure they're involved in decision making, like we're doing with discussing the 5P items. Finally, program is especially important in newer aircraft with instrument displays, GPSs, and autopilots. While these allow for advances in situational awareness and task management, mistakes are easily made and changes in programming need to be made regularly. SRM is kind of the science of using all available resources to ensure the successful completion of a flight. One of those resources is automation. Electronic flight displays, like this Garmin system using the Barons, describes all kinds of information that allows us to reduce clutter in the cockpit, help prevent controlled flight into terrain, and improve task management. However, these tools are only as effective as what the pilot has told it to do. It is essential that the pilot is proficient in its operation and ensures the database is current and performs regular checks to make sure the information he put in is accurate. It is important to triple verify the autopilot is correctly programmed to do what is intended. Additionally, a pilot must maintain their ability to operate without these systems in case there is a malfunction, or it must be turned off after an input error. If an autopilot ever does something we don't want it to do, we simply turn it off and fly by hand, then fix the issue. It is always a good idea to call out or talk through using automation, but I will especially make sure I do this for this flight to keep my passengers on board. I would also explain some of the systems such as propellers and what my response would be to some emergencies such as prop blade failure. Hopefully this would ensure they are confident I know the aircraft. According to the Airplane Flying Handbook, multi-engine propellers differ from constant speed single-engine propellers. In a single engine, oil pressure increases pitch that it fills in the low pitch high RPM setting. The opposite is true for multi-engines. Oil pressure decreases pitch so that if there is not enough oil pressure, it quits in the feathered position. With the other engine still operative, this increases efficiency by reducing parasite drag and increases controllability. A windmilling propeller pushes the blade into the low pitch, high RPM setting. To counter this, counterweights are attached to the shank of each blade. Centrifugal force acting on these weights force the blade into the high pitch, low RPM setting. With the increased complexity of multi-engine propellers, pilots should pay extra attention to the propellers during pre-flight. AOPA explains that during pre-flight, pilots should ensure the prop is clean and free of grime. There are no nicks greater than 1/32 of an inch, wide or deep and free of numerous nicks, and the blades should be tight in their sockets with no more than the slightest bit of movement in them. If the blade does fail in flight, it can cause severe damage to the aircraft and vibrate violently. To deal with the failure, the pilot should remain calm, reduce power. With 2 engines, I would probably secure that engine that complete the emergency checklist for one engine inoperative and land as soon as practical. Some might say to get to an airport, but if I have structural damage or may have structural damage, I think I'd make the call to just get on the ground before it weakens further. There are two types of emergency landings, forced and precautionary. A forced landing, as the airplane flying handbook describes, is an immediate landing on or off an airport necessitated by the inability to continue further flight. A typical example of which is an airplane forced down by engine failure. A precautionary landing is a premeditated landing on or off an airport when further flight is possible but inadvisable. Examples of conditions that may call for a precautionary landing include deteriorating weather, being lost, fuel shortage, and gradually developing engine trouble. Precautionary landings are less hazardous because there is more time to determine a safe place to land and engine power to get there. Precautionary landings may develop into forced landings if the pilot uses wishful thinking instead of reason. For emergency landings, I like to use the ABC checklist. Airspeed, best landing site, checklist, declare emergency to ATC or guard, and then the emergency landing. With two engines, we might have more built-in redundancies and are more likely to experience a precautionary landing rather than a forced landing. However, needing to secure the engine and put in control inputs to counter the asymmetrical thrust will increase workload. These are the references used to make this presentation. And again, my name is Justin Lara. Thank you for watching.